back. Our next speaker is Daehyok Shin. Daehyok is a hydrological modeler working for the Australian Bureau of Meteorology. And his talk is on Python for water forecasting services. Please give him a hand.
All right, thank you for attending my presentation. Maybe this presentation is not the most, but the least maybe the technical presentation maybe in this conference. But I hope this can be some interesting to attract your attention. Okay. All right. Okay. If you visit this website, okay, you can see a list of Bureau's new water resource information service. Okay. And in this presentation, I will introduce several water forecasting services in this website. And also, I will explain how actually Python helped us in developing the robust and reliable operational modeling system, even with the limited resource we had. Okay. And more specifically, I will talk about the seasonal Streamflow forecasting service, 7-day Streamflow forecasting service, hydrologic reference station service, and the new service we are developing, the etfs catchment water quality forecasting service. Okay, let me start my presentation with the millennium drought. Okay, everybody maybe remember that. Starting from 1995, this exceptional and decimating drought actually dried up most area of Australia. You can see the 2007 Hume Dam, the pictures there. And finally, in 2007, Australia society actually was pushed to the almost its collapsing point. Okay, so in response to the crisis, the Congress registered Water Act 2007. Maybe you heard about that. And under the mandate, the Bureau actually took a new role about the water information. So the Bureau actually can collect, manage, and disseminate water information data across Australia, even from private company or the private person. Okay, and also it expanded its forecast role to provide not only the flood forecast but also seasonal, decadal water availability. Some forecast. Okay. So at the time, the Bureau recruited about 60 new hydrologists. And I was one of them. And I joined the Bureau in October 2008 from University of North Carolina, Chapel Hill in US. And you can see the one symbol of the UNC. It's called Old Well. And anyway, when I got an offer from the Bureau at the time, I was super excited about that opportunity because I got a bachelor degree in computer science and the master and the PhD in hydrology. So I really wanted to have some opportunity to apply best software engineering practice for environmental modeling. So when I joined the extended hydrological prediction section, I got a responsibility to make a transition of a research product to fully operational, the system and the service for water forecasting service. Okay, that was great, but I got a serious challenge there. Okay, we had initially only 5 members in the project team, and I was the only one person who had a professional software development experience. And in addition, we were asked to complete the entire transition from research to operation. We are calling TROPS within just 1.5 years. From scratch, okay, to the fully functional system. So how can we finish, these TROPS? In other words, how can we design, develop, and deploy fully operational system and reliable operational system for this mission-critical public service? Okay, and so we really need, the highly productive, and the effective software development solution. Okay, the other side is. We actually work with the CSIRO and the university research partners. They already developed, the big, ugly, the monolithic manufacturing programs for their own, research purpose. So one challenge is, how can we effectively glue those legacy Fortran programs into one nicely integrated modeling system, which also should provide, the one consistent and productive user interface to our modelers. Okay? And the more fundamental challenge is about the communication. Okay? In our project, we had researchers, service operators, software programmers, managers, and the users. Okay? So how can we overcome this communication barrier among the different people from the different background and the different roles? Okay? Fortunately, I already knew the one technical solution to overcome the challenge. It was to develop the entire system using the very highly productive and easy to use the programming language, which is Python, right? And at that time, as a Python programmer, we already have the 6-year experience. I started using Python using numeric, okay, not the NumPy, okay, yeah. And I was confident that Python can be it could be the technical solution, which actually help us to overcome this challenge. But at that time, 2009. When I proposed to use Python as a main development language for our first operational system, the first question I got is, what is Python? Okay, from my managers and from other the project team members. And so I had to overcome very strong resistance. First, at that time, I could not find many talented Python programmers in Australia. Okay, and also, I was not even allowed to mention Python programming skill as a one selection criteria when I actually tried to recruit, the new system developer, because it could end up, the too few applications for the position. Okay, and instead, I was even advised to use, believe it or not, C# to develop this system, because at that time Microsoft really pushing hard to sell its .NET framework. Okay, that was the 2009. Fortunately, but I could persuade my supervisors in some way, and we became the first project team who actually developed the water forecasting service using Python solutions in the bureau. I think the real value of Python is not just about the one productive and popular programming language. The elegant and the easy to use, easy to learn, and also almost the pseudocode kind, that syntax can be used as a common technical language, which can bridge people from different backgrounds, particularly hardcore the software developers and the scientists and the engineers. Okay, so when I introduce our modeling system in this presentation, I would like to emphasize that human factor rather than the too much technical details. Okay. All right, the first service we developed, it's the seasonal Streamflow forecasting service. If you visit this website, you will have a 3 months Streamflow volume forecast for gauged sites and the reservoir across Australia. Okay, the forecast updates every month. Currently, the service is covering about 150 sites, and we have a plan to expand the coverage up to 350 sites by the end of next year. Okay. The service actually provides both statistical, modeling, the product. It's actually identify the joint probability between climate index and the Streamflow data. Also, the dynamic modeling method. It's basically, run the hydrology model with the rainfall forecast from Bureau's global climate, the model. Okay, I will not touch that details part. And the service actually was designed to provide useful information about, particularly about drought onset and recovery forecast, and the water supply management, water allocation, dam operation plans, and the irrigation. The underlying modeling system is WAFARI, the water availability forecast for Australian rivers. We built up the entire system by the coupling the various models and tools with the Python, at the center, Python interpreter. This system actually provides a variety of tools, for data ingestion and the parameter sampling, forecasting, reporting, and even very complex, forecast verification process. All input and output data and intermediate data actually stored in the HDF5-based self-descriptive data with their own, the metadata information. And we are using the PyTables to handle these HDF data files. The entire system was constructed as the Python packages, so modelers can import the entire WAFARI system in their program and automate the work process for complex modeling process. Okay? And the pandas time series is one of a standard data type. All integrated system component actually exchange the data. Okay. WAFARI, as I said, WAFARI is coupling, the many Fortran, the model kernels there, and one of them is a statistical Bayesian joint probability (BJP) kernel model, from the Seaside research partner, and the BETIA model calibration component from University of Adelaide, the team. And when actually we initially had this Fortran program from our research partner, okay, we found those Fortran program is just a big, monolithic, ugly, the typical science, the scientific program, which only can read the data, and write the data, through files. Okay, so for the initial coupling, we didn't have any other choice, except just the loosely coupling the kernel, by using the file exchange. Okay, but as you know, to improve the overall system performance, it is very critical to implement the efficient coupling between these model Fortran kernels with other Python programs in WAFARI. Particularly, they needed to exchange, the multidimensional, the large arrays. So after we finished this initial coupling, we sat down together with our research partners and defined the minimum API functions for their models. And we worked together to decompose their monolithic Fortran program into small, reusable models. And then using the F2Py, we actually seamlessly coupled those Fortran models with WAFARI, so they can exchange the NumPy, the array directly without actually doing any internal cloning. Okay, that's really important when you build up the scientific engineering the system. Sorry. And the WAFARI actually provide many tools for this kind of the highly customized graphic product designed for the service. Okay? And when we designed this highly customized graphic product, we actually went through the numerous iterations with our stakeholders. Okay? During the process, the rapid prototyping capability of the Python and the MATLAB actually really helped us in going through this iterative and time-consuming process. Here is one example. Okay, well, starting with this very rough hand-drawn, the graph. Whenever we have a new request or new comment from our stakeholders, we quickly revise the graph and then send it back to them and ask stakeholders more specific comments on the revised graph. So during this process, from the revised graph, stakeholders could see what kind of visual impact their recent the request or comment actually made on that product. So they became more and more engaging in this design process and try to provide more specific and valid feedback for each element in the graph. So in this process, Python and the MATLAB effectively connected, our graphic designer, product developer, and the stakeholders, so they could rapidly, reach some agreement on the final specification of even this, the highly customized some, the graphic product. Okay. All right, next service, 7 days Streamflow forecasting service. This service actually provides hourly and daily Streamflow forecast up to 7 days ahead. So it's kind of a little extended version of current, the flood forecast. And this forecast updated every day, okay, already available to the public. And this service actually covers 62 catchments right now, and we have a plan to add 40 more catchments by the end of next year. And this service, this forecast is particularly useful for dam operation, river system modeling, and the irrigation. Okay, so you can see the some MATLAB, the base, the graph in the website there. Okay, the underlying modeling system is Swift. And recently, our CSIRO partners delivered a new version of Swift 2, we are calling, and they rewrote entire Fortran program, to C++. So the bureau actually, was responsible for the development of a Python wrapper for this C++ program. And actually, we wrapped the C API. It's called the PySwift, and also we responsible for the deploying the system for this operational service. Okay. For the coupling, we use the CFFI to create a one-to-one mapping, between the Python function and the Swift C API function. Okay. And for efficient data exchange, we enable the Swift C++ program directly access the memory buffer in the pandas time series. Okay, and also right now, on top of this shallow, the PySwift the wrapper, we are adding the more and more, the Pythonic design to provide the intuitive user interface to our modelers. Okay, and also we set up the dedicated Jupyter Hub server for Swift modeling and the training. And so using this interactive, the simulation environment, this is the way we transfer the knowledge of a new system. A few core developers actually trained, several selected, the advanced modelers for each group. And then the advanced modelers actually trained the other service operators in their groups. Okay, and in this knowledge transfer, Jupyter Hub's interactive and interactive environment are really helping connecting these people. So here is one of our advanced modeler, the Einar Kabir. He is right now really busy in drafting the Jupyter notebook, to teach service operator, how to construct and calibrate and generate the 7 days Streamflow forecast. So in this way, the Python and the Jupyter notebook became some intrinsic part of our training program. Okay. Next service. Hydrologic reference station service. It's about the data, long-term data. It actually defined the reference Streamflow data for water availability analysis. So this service actually provide high quality Streamflow data for more than 200 stream gauges across Australia, and each gauge has at least the 30-year continuous unregulated Streamflow record. So with this data, you can also see the long-term trend analysis and change detection, the result. Okay, so you can see here, the Western Australia, this is a long-term average, and Western Australia still, we can see under millennium drought. Okay, they never recovered from the millennium drought. Okay. All right, so underlying data analysis system is called the HRS Toolkit, and it provides the tools for the data gap filling and the temporal aggregation, statistical summary, and particularly the step and the linear change analysis on the Streamflow data. So for instance, you can see some example, the Harvey River site, about the 1994, you can see the totally different, the rainfall annual streamflow volume pattern compared to the, the before the pattern before the 1994. Okay, so almost a step change. That we can see that. Okay, and we extensively use the tool in the SciPy stats, the tools for statistical analysis. And again, the entire system actually was built as a scriptable, the Python package. Okay. And the next one, etfs catchment modeling system. This system is active development to provide the daily water quantity and the quality forecast, such as sediment and nitrogen, up to 30 days ahead. And this service will cover 25 catchment in the Great Barrier Reef area. Okay, so once we have finished this development, this system actually will feed the input data to marine modeling system, including the ROMs. And so, we can see that the impact of a catchment nutrient and the pollutant to this precious marine ecosystem. Okay, and again, the entire system actually is developed as a Python package. We are using the Pandas, SciPy, and particularly scikit-run package, for the analysis. Okay, the future work, future development, and from the aspect of Streamflow forecast service, we have a long vision to provide, we are calling the seamless Streamflow forecast. It's basically through one single web portal, it actually provides a multi-temporal scale forecast from flood, and the daily, and the monthly, and the seasonal, and the decadal forecast. Okay? So that is a wrong, the vision we have. From the aspect of system development, the first thing we have to do is we needed to port all our modeling system from Python 2 to Python 3. Okay? So we can leverage the advanced features of a new version, such as metrics, the multiplication operation, and also we want to use a new version of Jupyter Lab, okay, in the near future. Another area is we can use the huge the parallel computing power of a new Bureau's supercomputer. It's called the Australis, okay, particularly for our computationally expensive the forecast verification process. So until recently, we just have about 100 teraprop. You can see there. But from this year, we have about 2,000, and from 2019, we will have a 5,000 teraprop. So we are really excited, to use this kind of the high performance computer for our modeling. And another area is you can see we use the Mapla library to generate just a static image for our product. So we wanted to replace those products with a more interactive, dynamic, the chart using hopefully Python-based or JavaScript, the based graphic library. Okay. Okay, and then finally, we tried to get the approval. It's already quite difficult, than expected, but approval to share at least some of our key model component with the Python community as open source. So we try to return at least some fraction of benefit we had, back to the community. Okay. So in summary, after long journey over 7 years, okay, Python became key factor for our successful trials. For many, the water forecasting system and the service for Australian public. And Python played a key role, particularly as a bridge connecting the not only different programs, but also people in different roles and from different background. And after the long journey now, the Python programming becomes one essential skill required for not only our system developers, but also all our, the hydrology modelers, okay? And as you can see from our, the recent job, the advertisement, I can finally ask Python programming skill as one essential selection criteria for new system developer position. Okay, it was a big change after 7 years, and I'm feeling I was privileged to seize this opportunity to realize the potential of Python in developing the really mission critical the public service for Australian public. And if you are looking for this kind of the opportunity to use your Python skills, just to let me know. I always the hunting for that kind of talent and passion. Okay. And if you wanted to know the more technical details, please check a video over, because they already gave the presentations, a video over these two presentations from my colleague, the Kevin and Andrew. And this is the recent the picture of not quite maybe the last year picture. Yeah, but it's really difficult to convene. All people are actually convene in the same place. Our section, and 1/3, 2/3 of members are hydrologists, and 1/3 are system developers, and using the English and the Python as a common language, we are happily working together as one team. Okay, thank you very much.
Thank you, Daehyok. All right, let's open it up for questions. I'll start here.
How much do the new computers cost?
Computer?
The Cray computers, the new ones. 1660 and 5000 megaflops, teraflops.
Oh,
He wants to buy one.
In fact, the forecast, the Streamflow forecast service every day, every month forecast, we don't need any supercomputer structure. But we are calling the cross validation forecast verification. We need the quite massive the high performance supercomputer structure. I could not say how much actually we need, because right now it takes I can give you some example. We are using the NCI machine right now, because we didn't port our program to new supercomputer yet. So in NCI machine, usually 2 weeks it takes when we start the forecast verification exercise for the 200 sites for seasonal Streamflow forecast. So we really wanted to compress that time to several days. So whenever we make any change in the modeling method or new component there, we quickly rerun the forecast verification, so identify what kind of benefit we have with that new method. Yeah, so that's why we are very excited about the new supercomputer, Cray supercomputer, in the build. Yeah.
So how much work, or how difficult is it to convert all your code to stuff that can work on supercomputers over what it is currently now?
In fact, the software side, not that much. The compiling and other things, because right now the most Python package and the libraries, we are using actually the quite platform independent. But to be honest, having the support. The IT support within the organization for the reporting actually sometimes takes more time. So they bureaus, the organization, so many people, and the supercomputer is managed by the different the division. So our division director actually have to talk with another division director and that kind of thing. But software itself, it does not take much time, but actually, we needed to improve some code to efficiently use the parallel computing cluster structure more efficiently. That is the next step. Okay. Yeah.
Do you intend to phase out your old Fortran programs, especially because with bringing in sort of new Python talent, I suppose there'd be less people sort of on the ground who'd be able to actually support those?
Would you tell me again?
So I'm assuming you've still got some old Fortran programs running somewhere?
Yeah.
Do you intend to phase them out, perhaps replace them with Python systems?
Okay, all right. Yeah, that's a good question. The answer is no in the near future, because we have a partnership with the researchers, and our researchers actually keep improving their the modeling method, but they embed that the algorithm in their Fortran program. Okay, so we wanted to use their improve the Fortran program whenever they actually make any the improvement. So if we translate the Fortran program into Python or other things, some actually the algorithm we can actually translate, okay? Because we understand the algorithm, but we are reluctant to do that because they are happy about their Fortran, the coding, that capability, and we wanted to respect their research area. Yeah.
All right. Sorry, we've run out of time. Okay. Let's thank Daehyok once again.
So, not that much technical, right? Okay. All right, I have to give this one.
My university friends I last knew of was at the Bureau of Meteorology.
Oh, okay.
Computer division.
All right, okay.
John Land.
Oh, okay. Nice to meet you.
Anyway.
Yeah.
I suspect he may have retired now, because I have.
So, not that much technical, right? Okay. All right, I have to give this one.
My university friends I last knew of was at the Bureau of Meteorology.
Oh, okay.
Computer division.
All right, okay.
John Land.
Oh, okay. Nice to meet you.
Anyway.
Yeah.
I suspect he may have retired now, because I have.